So now we're going to define a new vector, but before we do that, let's recall some facts. So the first fact we're going to recall is that when I take the dot product of a vector with itself, you get back the magnitude of that vector squared. But remember that this vector t that we mentioned last time, this is a unit vector, and so its length is 1. So now I know that t dot t is 1. And then if you refer back to the derivatives video, I listed some properties of the derivative. Because this dot product is a constant, I know that t dotted with the derivative of t would be 0. So what does this tell us when the dot product is 0? It tells us that these vectors are orthogonal. So t prime is orthogonal to t. All right, so now we're going to define our new vector. So we're going to again suppose that C is a smooth curve represented by R on an open interval I if t prime, if the derivative of our unit tangent vector is not 0, it's not the 0 vector, then we can define the principal unit normal vector at t is defined as, so it has the following formula. N of t is t prime of t over the magnitude of t prime. So I can tell based on this formula that this vector n, it's a unit vector. And we use the phrase normal here because remember that this t prime, we said it's orthogonal to t, so you can think about orthogonal and normal here. So let's look at an example where we find this vector. So let's go back to our previous example, find the principal unit normal vector for the helix R of t. It was 2 cosine ti plus 2 sine tj plus tk. Well, in one of our previous videos, we already found t for this helix, our unit tangent vector. So I'll just say we previously found t. It's 1 over the square root of 5 minus 2 sine t I plus 2 cosine tj plus k. So now if I want to find I'm asked to find the principal unit normal vector, I need to find the vector n. So I need to take the derivative of the unit tangent vector. So t prime, take the derivative here. You'll get minus 2 cosine ti minus 2 sine tj. The derivative of 1 is 0, so there's no k component anymore. And then if you find the magnitude of this vector, the magnitude of t prime, you should find that the magnitude will be 2 over the square root of 5. So we can now find our principal unit normal vector, the vector n. So remember that it's t prime over the magnitude of t prime So here, if I divide, the square root of 5s will go away. I get 1 over 2 minus 2 cosine ti minus 2 sine tj. And then if I distribute that 1/2, I'll end up with a minus cosine ti and a minus sine tj. And this is my principal unit normal vector n that I was looking for. So when you're asked to find this principal unit normal vector, this vector n, you have to find the unit tangent vector t in order to find this vector n.